Hello, everyone. Thank you so much for joining us today on the Dagger community call. We really appreciate you taking the time out of your day to come join us. We want to make this as interactive as possible. So if this is your first community call, thanks for being here. A great place to be also is our Discord channel. That's a place that we're talking all day, every day, almost every time zone. People are in there talking about the ways that they're using Dagger, but it's also where our whole team is at. So if you have any questions on either any of these demos afterwards or questions on getting started with Dagger, that's a great place to be. And if you're joining this call, we always love having guest speakers on here. So if you'd like to demo here, just give me a shout out on Discord and I will be happy to add you to the agenda. Another way to chat during this call and give all your questions or comments during the demos is in the YouTube chat or any of the chats that you are watching the live stream from. We'll see that and then interact with it during the demo as well. So send all of your questions and comments, memes on the Discord, whatever our way. So before we get started into actual demos though, let's talk about who's here and what we're doing today. So we have a few of us. Jeremy, co-host, you want to introduce yourself? People who may not know you.
Hey, everybody. Jeremy Adams. I'm the head of ecosystem at Dagger. And so you see us in there, some of our folks like working on integrations or, just working with the community or like thinking about a new blog post to showcase something cool that we're doing or we've seen. So reach out on Discord. I'm there all the time and I love to connect with you.
Sweet. And I think we just had someone do that yesterday for our GPU blog post. So really excited to see that already. There's a meeting. I think you had a meeting this morning. So if you reach out to us, we'll be quick to get to know you. Awesome. Thanks, Jeremy. Sam, what about you?
Hi everyone, I'm Sam Alba on Discord. I'm a Dagger co-founder, and today I'll show you a quick demo after Alex actually on how to convert Docker file to Dagger module as an easy way to start instead of blank code or boilerplate. You can start Dagger module from an existing Docker file, and hopefully we can that can be the beginning of a great conversation either here or on Discord later.
Awesome. Sweet. And Alex or Vito?
Hi, I'm Alex, aka Vito on Discord and GitHub. I'm kind of back-end turned front-end engineer lately, so I'll be showing the new V3 UI that we've been cooking up for cloud.
I'm excited to learn more about how everyone's suddenly a front-end engineer as well. Awesome.
That's right.
And Solomon.
Hi, I'm co-founder of Dagger. Just happy to hang out with everyone here and show the demos. And hopefully my demo will work this time. But
Nice.
I've been playing with some unusual use cases for Dagger and want to get your thoughts. So
Awesome. And if people were on what I think it was maybe the last community call, Solomon was doing some AI demos as well and walking through it. And if you are new to this channel, we like to test things, just see where the wind takes us sometimes. So as we're going through these, or you have comments or you see something we're doing, you're like, hey, maybe try this, like go for it in the comments and interact with us. We're excited to have you all here and talk through some of this stuff. So
hey Miranda, last time halfway through when all the demos were breaking, you noted that we had forgotten to give an offering to the demo gods. So maybe this time we should.
Right. You're right. Yeah, I know. Do we have anything? I have one earring that my kid finally found. was in there.
Well, don't sacrifice it. I'll go pour a little bit of tea in the garden while you guys get
Pour
started.
one out for the homies. Yeah. Love it. Okay.
I mean, that means a lot, because for Solomon, like, tea is his life's blood. So he's actually giving something he cares about.
He's gonna need a.
I try to do it with a dramatic gesture, so the gods are merciful.
Yeah, he needs a refill during the demos. So during Sam's demo, he'll go get a tea refill.
Oh no, I can't. I don't want to miss that.
Awesome. And we have so many people joining us from all over today. There's Guatemala, Argentina from our team. So
everyone.
it's great to see so many people from all over the place. Thank you for joining. It's always hard finding a
They're all here for Alex.
For sure.
Right, exactly.
Sure.
I know.
Appreciate the sacrifice.
And then someone's even watching us from a train in France. So this is really cool. Thank you everyone for being here.
See, Miranda, what I really want to know is, what is the preferred distance from the camera for our viewers? So if you have comments on that, I'm pretty close. Miranda's, kind of a nice casual, cool.
There
we go. Alex wins.
That's better.
Yeah, I'm like, yeah.
Oh, I love it. That's perfect. Perfect.
Amazing.
I think, are we going to be one of those TikTok videos where, like, when we have all the things, everyone sends recommendations? Like, I want the recommendation for your headphones, Alex, because those are super cool.
Totally. We'll have the links, so we get a couple cents each time.
I was going to say, we're actually affiliate marketing now. Dagger community calls. Oh gosh, awesome. Well, let's get I want to show off some of the awesome stuff. So Alex, you're going to show us, I think, some of the stuff that we've been talking about for Cloud V3. So if people haven't already seen the blog post, I'll put the blog post in the channel or the comment section. But we just announced kind of some latest stuff that we've been working on there. So Alex is going to go into it a little bit, and then I'm sure there's some questions around like some of the other stuff that we of how we built this, which is coming up. But I think Alex will talk about it a little bit too. So let me pull up your screen, which I don't see. You might have to attach it again.
Yeah.
Perfect.
1 second. Screen 2. Okay, there we go.
Sweet. Let's add it to the stage. Awesome. Let me make it bigger. There we go.
Cool. Good to go?
Yeah, you're good.
All right. So yeah, I'll be showing Cloud V3, and this is currently Cloud V2 because I figured, it's opt-in, so you might not know where the button is. It's right up here. So if you're browsing Cloud V2, you just click V3. That'll kick you into the new UI, and it also it'll make it remember. So if you navigate to V2 from an old link from like a GitHub check or from the CLI, when you press the W key, it'll redirect you to V3.
And that's huge for some of our users that like our power users who have been testing this and giving us feedback for a while, because we've been having a separate link and you literally have to use that separate link. Now it will remember. So that's something that is awesome.
Yep. So the first thing I guess I'll talk about, because it's really quick. Now you can actually pick light mode if you so desire, if you're one of those people. I prefer dark. Well, actually, I prefer system, but then I always leave my system in dark anyway. But yeah, the first thing you'll notice here is instead of having like a CI page and then a local traces page, it's just all in one. So that just skips an extra click. And one of the main things that's different is this new UI is written in WebAssembly using Go. The main reason for that is just so we can share code with the TUI. So now all the logic that's driving this is the exact same that's driving this. Once it loads,
Nice.
1 second. And yeah, so one thing you'll notice as you pop in here is it actually sort of kind of smoothly animates. I think it might be lagging a little bit because I'm also streaming. But yeah, before it
is very smooth.
I made a promise when we initially announced V2 that we want this web UI to be incredibly slick and snappy, because when you're here, you're probably coming here because something is failing, so you're already in a bad mood, so you don't want to be waiting on the web UI to be lagging all the time either. So yeah, now this is kind of hopefully fulfilling that promise. Larger traces are definitely harder, but yeah, like one of the main things from going from React to WebAssembly is just there's so many more options that we have for optimizing. I don't declare myself to be a professional React developer, so someone out there is probably ready to bite my head off and say like, oh, you can make it as fast as WebAssembly. But the fact is, like, now we can just reuse so much code, and the new framework doesn't sort of force us into one single method of doing things. So I've been able to try a bunch of different ways to optimize everything. Yeah, that's it. Should be nice and snappy. So now I'll actually go over features besides performance. One of them is much better log handling. So you'll notice when you click into a failed build, now you don't have to like click deeply into it to find what went wrong. Everything that failed and has logs will be hoisted straight up to the top level. So now you can see, this actually failed deep under like go test sum, and then the exec that actually ran the tests, and then beneath the runtime suite, and then beneath the build kit suite. But here I can just see it right up top. And this heuristic is basically, as long as there's like sort of a chain of, parent child that failed, and there's logs to show, it'll just bubble it up. The other new thing is there are breadcrumbs, which I kind of pointed out already here. So now there's much faster navigation. Before you'd have to kind of pop up one level at a time, but now you can arbitrarily jump up and down the tree, which is much nicer.
Yeah.
There's also much better logging functionality. Before, it would kind of just render all of the logs at once, which if you had, hundreds of thousands of lines, which sometimes we do because we run the Dagger engine for our integration tests, it would kind of just like choke your browser and die. Now we'll actually only render 1,000 lines at a time, and it will render from the bottom up, which is usually where the things you're looking for are. And you can kind of tell it to render more. If I end up on a large build, I'll demo that, but there's like a play button that shows up here. The other thing is you can also grep the logs. So here I search for debug, kind of unfortunately not readable there because it's purple on yellow, but it highlights the matches. You can expand to show context for matches, things like that. So yeah, the logging setup is just overall much, much better, should perform a lot better, should let you find what you're looking for a lot better. Also, when you have it render everything, if you don't want to use this filter thing, you can just use regular old like browser control F, which is how I preferred to use it before, but it's just browser kind of chokes when you have 300,000 lines of output. Let's see, I already covered logs. One other thing I can mention is when you go into these are called, we never really had a great name for these. They're kind of like CI groups. It's like a set of traces that are associated to a commit. Now with one thing that you have here is you'll see all the traces, and then you'll also see this nice timeline. So you can actually see, when one trace started and finished. Before you kind of had to click into each of them and get an idea, but now you can see, oh, my whole like end-to-end CI suite, started here and then ended many hours later, if that's what it actually took.
Oh wow! So that's like global like time across, like real time.
Yeah.
Show it for one of our production CI builds, just to
I'm
get a
doing
sense
it
for what that looks
so
like when you're using Dagger for all your CI.
Here's a bigger one.
Yeah,
Wow.
This is much more impressive.
You can see what's happening in parallel, and
this is a CI job for Dagger that's currently running live on GitHub Actions.
Yep.
It just happens to be configured to run a bunch of Dagger pipelines, of course, and we can go see not just a raw flat wall of text to see what's happening. We can actually see like the structure of what's happening in real time. Basically, it's pretty. Yep. I love going to the dashboard and just seeing stuff happening ambiently, especially for a distributed team. It's so cool.
Yeah, like
Andrea working on secret providers.
Yeah, exactly.
Last time.
I got pinged by Jeremy the other night. He was like, "What are you working on? That looks cool."
Yeah, there's a lot more sort of passive information because like these local traces show what everyone's up to, shows their faces and stuff. I've been creeping on other people, like messing around with Michelle sometimes. Yeah, what are you
can even show. You should show the terminal. Actually, hold on. Let me go to that terminal right now. That's me prepping for my demo. Wait, where is it?
Yeah, go for it.
No, I don't know where it is. Okay. Oh, hold on. Do you see it?
One second.
See, which one is it?
I don't know.
Wait, let's go.
You can start a new one.
Which your open sessions is it? Let's see.
I only have one.
Oh, yeah.
No, that's
There's
my.
two.
That's the one. That's the one. Yeah. Okay. So now let me open a terminal. Let me open a current. Let me just fire up a container and open a terminal real quick.
Oh, there we go.
Oh,
Nice.
what?
Okay, I'm going to say a disclaimer here because this is probably not what you're typing.
Oh. Oh well.
Yeah,
The output works.
there's a technical detail here. Here, if I close and re-expand, it should work.
It's our anagram generator, isn't it? Isn't that like a feature?
It's because like everything comes in async, and then we try to like get it to the client as fast as possible. So sometimes it gets a little jumbled. But if you like close and refresh, it'll.
Let's see.
It'll be the
Okay.
right thing.
No, never mind. I was gonna try to run Dagger inside Dagger, but I'm gonna derail your demo if I do that.
It's fine.
No, actually, let's do it just to show, because this always
go for it.
blows my mind just how well designed this whole tracing situation is. Let me just what's this fastest way to do that? Oh, I guess I'll just download the official registry Dagger.io engine. Okay, I'm running that.
Is this in the same? Oh, there it is.
Yeah. Let's pulling the latest Dagger. I'm opening a terminal.
So if people haven't played with Dagger Shell,
Don't
this is a
see
good
it yet.
chance. You can see this is all happening in like one shell session, including
Oh, I see it.
There
Okay.
we go.
So now I'm going to open another shell session inside that one.
shell and shell.
And here I'm going to run another pipeline.
There it is.
And I'm going to open a terminal in that new container.
Nice.
We have to go deeper.
Let's go deeper. I don't know. Should we? I don't know. Oh, it's
No,
kind of.
I mean, it'll.
My terminal
it'll
is.
probably do the same thing.
My terminal is not happy right now.
Okay, well that's the end of
I
that.
just,
Let's see.
I was gonna say, yeah, it's just amazing to see how quick all of this is and how, in real time. Yeah, it's great. And for people
I
who
don't
are,
think this does not exist. I don't think anyone else can do this. This integration with the runtime and the tracing and all kind of just and the nesting. It's pretty amazing. I love using it.
The last kind of section I was going to cover is really like around statuses. So you probably saw, like everyone probably saw when I was viewing that, you had like the little yellow pinging animation. That's one thing that's new. It was kind of hard to tell what things were actually running in V2. Another thing is now you can see which things are cache hits, which V2 never showed. V1 did, but we never brought it back for V2. But yeah, this little recycle icon and dimmed span that indicates that this was a cache hit, so nothing actually ran in the engine for it. There's also pending indicators. I'm not completely happy with them. They're a little too subtle, but like the fact that this circle is empty means that there's something that this thing installed but never actually had to run. I think it's that this has like a default container that it sets up, but we just never use, so that ends up fooling it into thinking that it's pending. So yeah, there's some parts that still need to be patched up. Yeah,
Did anyone else figure that out already?
Probably not.
I didn't know that. I didn't know that.
Little Easter eggs in the tool.
That also is a reminder. If you tried Dagger Cloud and you're wanting to test out, like Alex said, you just switch over to the V3 beta. If you haven't tried Dagger Cloud at all yet, same thing. You're going to log into Dagger Cloud, but you'll still have to switch to the V3 beta because it isn't beta. So we are redirecting you to kind of this new URL, and we also want tons of feedback. So if one of these, like Alex is showing you, if it's not clear or you feel like something's missing or you're running into issues, please let us know either on Discord or on like GitHub issues. It's really helpful for us to keep moving fast with these changes. But Alex, you also mentioned something around how this, you were able to build this faster and now kind of be like a front end engineer. You want to touch on that a little bit?
Yeah, sure. So I'm very much used to like the Go ecosystem. I kind of hopped into front end for V2 and jumped into the world of TypeScript and React. And as you might imagine, didn't really enjoy that ecosystem. There's just a lot for anyone that's worked in it. It's just kind of trying to work in quicksand. It's always ever shifting, world to be operating in. And it's a language that I don't need to talk about that much. Anyway, I like Go. I like the tool chain that it has. I like the ability to, have fast compilation, native static typing. But honestly, the biggest thing is not really the language. If this was just like, oh, I love Go, I'm going to rewrite the front end in Go, it wouldn't be worth it. I wouldn't even advocate for that. The main thing is just that our terminal UI takes a lot of work to implement, and so did the V2 UI. And because one was TypeScript and one was Go, there was just no transferable work really between them. Technically, we might have been able to package up like the business logic as a library and call it from TypeScript, but even aside from just the business logic, having the ability to have the front end handle the amount of data that some of the largest traces throw at it was proving to be a challenge. And I made that initial promise of like, we want it to be incredibly snappy, and just didn't really feel like I was getting close enough to that promise. So that's when I started experimenting with WebAssembly and Go. And there's this nice framework that someone developed for Go, for using it for WebAssembly apps, which is pretty similar, honestly, in how you might think about React, with like, you just define a component, it has a render method, and then you build up a tree of components. It's like very much in the Go mindset of just there's one way to do things, and you just repeat that same pattern 1,000 times. And then at the end of that, you have like a large, complicated, but easy to maintain web application. So I feel like that's been paying off really well. We've already, the blog post before, we announced pretty much all the same features that I just announced here, with like the error log hoisting, the better statuses. There's just been so much sort of cross-pollination now between the terminal UI and the web UI. So we're able to deliver on both much faster, rather than before, where I'd have to kind of like take a month implementing terminal UI features and then take another month implementing the same thing in the web UI. Now we get to just leverage the same amount of work for both.
Awesome.
Yeah, honestly, for the exact team that we have, which is so Go centric and system centric, it's just perfect, right? We're like the perfect team to benefit from this change, as long as it worked, and it did. I don't know. Do you feel like? How do you feel about other teams asking? Because I tweeted about this yesterday, because when we launched, and I got a lot of questions and interest around this change, the change of how it's built specifically, from React to WebAssembly and Go.
Yeah,
and I think people are curious if they should do it, and is it something that's specific to us that made it a good idea for us, or should everyone just do it straight up?
There's a lot of things that made it specific to us. Like I mentioned, the terminal UI, web UI, being able to reuse that across both. Theoretically, I guess there could be a lot of teams that have that use case where it's pretty common to have a web UI and a CLI, but for us, the business logic was probably a lot more work to implement, like interpreting the whole event stream. I will say, like, if you are starting from scratch and you do like Go and you like its ecosystem, it's worth a shot. Because I feel like if you say WebAssembly, a lot of people are going to imagine something very low level and difficult to work with, but it's honestly not. It's a very high level way to implement a web application. There's a few quirks, like there's places where you'll be behind where you might start in React. For example, you don't have like the live page reloading as you edit code. You have to do like a hard refresh every time.
Just like tooling gaps.
Yeah. That, and there isn't really a set of like rich reusable components. Like I had to figure out how like modal dialogues work and stuff like that. Like tooltips. So there's a bit of like, having to implement things that you might not worry about. Like you might just, pick Chakra or something off the shelf. And that's that's for sure a thing. Like if you don't want to be implementing like modal dialogues and other primitive features, then I wouldn't really recommend it. But if you do have like a complicated web UI that you want to really be able to control every angle of for performance or UX reasons, yeah, I'd recommend it. I just wouldn't say, hey, if you're out there developing a React TypeScript app, you're doing it wrong. Go switch to Go.
To me, it boils down to velocity, really. Like whatever's slowing you down as a team to ship faster, you gotta remove that bottleneck. And for us, I mean, this completely changed the number of engineers on the team who can meaningfully develop on our front end, right?
Yeah.
And then for any given engineer, it also, like you described, it just breaks down silos. So you have, as an individual engineer, you have more end-to-end sort of ownership of the stack, and then more engineers can participate. So that in our case, it was like, I mean, I feel much better about our velocity now. I'm just excited to see what's going to ship next. Yeah. Well, we should give a shout out to the framework you're using, right?
Oh yeah, I brought that up here. I didn't really mention the URL though. It's called Go App.
Is it one guy? Just one guy developing it?
It's like primarily one or two. It's honestly a pretty small project, but they've gone like pretty far distance. It feels like with what they've been able to put together. It feels very, Go-like. Kind of seems like they figured out a really nice, repeatable pattern.
Nice.
Yeah. Well, a big thank you to them.
Yeah.
If you're watching, thank you.
Yeah. I just posted something on Blue Sky.
Nice
about it. Yeah, very cool project.
Nice.
I think I can call it there. I think I covered all the things I had to had on the docket.
Anybody have feature requests for Cloud, since we're all using it? Mine is a way to collapse, different way to filter spans, like really with one click or one keystroke.
Oh yeah,
like to show only stuff that's running or only custom spans. The filtering.
Go. There's a hidden feature for you there. If you click the little bendy pipe here, it'll actually filter out.
Everything's clickable. I should just. It's like those old adventure games. Let's just try clicking everything and see what happens.
Yeah, I'm something of a web designer myself.
You got to click on the stars. One of the stars is clickable. There's a hidden feature.
Yeah. Eventually, I'll figure out the proper way to represent this. It might be like a set of filtering controls appear here because there is this gap or something. But for now, you just click the little bendy button.
Yeah.
One of the questions I was to close out is when it comes to compilation and WASM release, is it a smaller footprint in the browser compared to the compiled React app?
Oh, that's a fun question. So if you do nothing, it will be a large binary download, but we've done a lot of things. So here, if I try to do a hard refresh, we can try to look at the bundle size. Once I stop filtering, there should be somewhere in here, there's a WASM file, and I'll zoom this in because it's tiny. So we're down to 4.6 megabytes. I don't remember exactly what it was, but it might have been like 32 megabytes before. The trick is to use Brotli compression because that, it's such a simple thing that you can do. Well, okay, sorry, it's not simple because you have to put it in your build process because Brotli compression takes a very long time. You can't just have it happen on the fly. We tried to do on the fly Brotli compression in Cloudflare, but the file is just too large to support that. But yeah, it's definitely something you have to be concerned with a Go WebAssembly app. But here, let's do it. Switch back to V2 and see what the overall download is. So clear this and do a hard refresh and try to time it.
And while you're pulling them up, there's also comments that you're using Windows. So there were some other proud Windows users.
Yeah, I got Notepad++ installed now in my taskbar. I remembered it exists. But yeah, so V2, we're looking at 2 megabytes transferred. So it's definitely bigger, but it's cached incredibly heavily. So you shouldn't really be feeling it in practice once you get it downloaded.
Awesome.
Oh, sorry, I just remembered one other thing. It's actually shipped as a progressive web app which means if you are able to find the UI control in your browser, you can actually click a button to install it. And then you can have Dagger Cloud like just in your taskbar or as a mobile app on your phone.
Nice.
This has been kind of nice. I just sort of leave it on my other monitor and then keep an eye on things as they come up.
Well, that's the hidden one that I didn't know about.
Yeah.
It's hard to find.
I do have one more question. Speaking of hidden features, there's one that I think is actually potentially huge, but we don't talk about it a whole lot yet. Maybe we will in the future. It's that Dagger Cloud can trace everything that the Dagger engine does, obviously. So you can trace your builds and your tests end to end.
Mm-hmm.
But then, since those builds involve running various tools that themselves support OpenTelemetry instrumentation, and we implemented all this in a fully interoperable way, Dagger will pick up the OpenTelemetry spans from the tools it's executing, and then Dagger Cloud will present them in context, right?
Yeah, so that's actually how this part works. These are just like OpenTelemetry spans.
So yeah, I just want to emphasize that because maybe people watching are overlooking this, but you're tracing what Dagger does, executing this, executing that, and then within that, the tool itself, this is Go itself, right? Sending OpenTelemetry spans in this case because we're running Go tests, and so we can visualize the individual test as a span in the context of the Dagger pipeline that's running it.
Yeah.
And in theory, you could do that for a lot of other tools. But I'm also curious, my question is like, what do I do to actually enable it? Because I think in our case, there's like a tiny little bit of glue we had to add to our test suite or something.
Yeah. So I actually yoinked that code out of our repo and into the base repo, which I'm using as the demo here. But we should probably turn this into like just a package that lives on its own for other people to use. But yeah, there's this bit of glue code because Go's test framework is not really amenable to instrumentation. They're kind of like, stuck with backwards compatibility concerns. Ideally, what you would have is like each test also takes a context, and then that's how you can sort of have a tree of tests and subtests being instrumented with OpenTelemetry. So for that previous UI to work, I had to write this little framework called test context, which is meant to be like, imagine we're in a world where context existed when, Go added the testing package. So it tries to be faithful to testing T, like no like controversial like BDD style testing. It's, just plain old T.run, but now you have a context argument. And along with that, it has support for middleware. So there's a OTel middleware. So you can enable OTel tracing as middleware for all tests. You can add OTel logging.
There's this glue is not actually Dagger specific. It's an upgrade to Go testing so that it's OTel. Like you could use this and then get your tests into Grafana or whatever, right?
Yeah, or anything that accepts OTel. Yeah,
right.
Some like Ruby, for example, I believe there's a RSpec like plugin that you can just install.
So would in that case, that would just be drop in for us?
Yeah. So like if you just, put this in your RSpec config, where did that go? There's like a gem for it. Yeah. OpenTelemetry instrumentation RSpec. Ideally, it would be as simple as this with Go, but that's just not the world we're in with compatibility reasons.
There's a related question that came in, and then we probably
Amazing.
We'll move to the other demos because we have so many. Do these external third-party telemetry appear on the TUI too?
Yep.
I think we kind of went through that. Yeah.
Yes.
Yeah, it's all the same stack. So it's also how you were seeing those spans show up over here.
Nice.
Oh, let me share for the TUI a hidden feature that I was so happy to find. You can call Dagger -- no exit or -E.
Oh yeah.
And what it'll do is when it's done, the TUI will stay there, and you can continue to navigate the trace after it's done running. And I know some people watching are like, hell yes, because it's so annoying that to not have that. But it's really nice.
Nice.
Oh, this is actually a bad way to demo it because this never actually exits. But yeah, in principle, just imagine it exited and I'm just browsing around.
Oh, because it's a long-running service or something?
There's a test that hangs that I have been meaning to fix for like over a year now. But yeah, these spans are just emitted with plain old OTel, and then the TY picks it up and it also gets sent to cloud. So that's how
awesome.
All that's working.
Thank you so much, Alex, for the summary. This is really cool to see. It's always exciting when we even learn things on this, like the app experience. So great to see. Like we mentioned, if you're already on Dagger Cloud, go on there, log in right now, change it to V3. Let us know what you think about it. If you're catching any issues, please let us know about it as well. And then if you haven't done Dagger Cloud, sign up, and then you'll still have to do that V3 transition on the toggle on the top too. So very excited to have everyone in there and hear your feedback. So, thanks again. Then Sam, I know you had a demo as well today around more modules.
Yep, I do.
I need to figure out how to have Dagger Cloud just always on the a bottom while we're doing all these demos and see what we can see with these active ones on the side. That would be cool.
Oh yeah,
But go for it, Sam. I'll figure it out.
Yeah. Yeah, great. So I will. So after this great demo of Dagger Cloud, I now show you a simple way to bootstrap a Dagger module. So as you know, Dagger is programmable and has a complete API that allows you to do many different things, pretty much any kind of automation. And sometimes some users ask us, where should I start? And I'm going to show you a simple way to start, which is starting from a Docker file. So everyone understands the syntax of Docker file, and everything you can do in a Docker file, you can do it, express it in the Dagger API. And obviously you can do much more, but it's a good starting point to start with something that you know and that you can then take and evolve. So I wrote a module that's called Docker to Dagger that contains a conversion function that basically takes a Docker file as input and output a new Dagger module. And I'll show you how it works. I also wrote README. So what I'm going to show you now, the idea is that it's not just to show you, hey, look at this cool demo that's really powerful because it's actually using AI and all that stuff. It's actually the goal is really to give you something that you can use. And so I'm gonna walk you through the README that I will post actually on the chat. And if you want, you can posting the comment. Here you go. So if you want, you can follow along. Everything that I will show you now, you can basically redo it on your side following the README, and the code is open source, obviously. So as a starting point, I will take an example project with a Docker file. That's not too simple, actually. I picked something that is interesting. It's an example from Docker, actually, that is in the docs. It's a to-do app. It's a small to-do app, but the thing that's interesting in that to-do app is if I open the Docker file, you'll see that it's not the classic Docker file that's 5 lines of code, and it actually uses several build stages, and so this is when it gets interesting to translate this into a Dagger pipeline. So in order to convert it, you don't have to clone my module. Actually, you can use a Dagger module directly from Dagger, so you only need Dagger installed. And you can directly copy paste this command that I will explain to you. But basically, you load the module remotely. So again, you don't have to clone the code. You call the function from Docker file and give some arguments. So it has two different arguments: an API key for Entropic. So as I mentioned earlier, I'm using an LLM to translate the Docker file into a Dagger module. So you just need an API key to access that, and you give the Docker file as an argument. So it's basically the file that's in the project. It's this file right there that I just showed you, and then you export the content. And so the interesting thing is the Dagger module will create a directory and generate the complete module and export it in the new directory. So you can give it a name like I don't know, my module, for instance. And so I will run it and see what happens. So it's basically reading the file, and then it's asking the LLM. It provides to the LLM a couple of examples, and that's actually I'll show you this part after I will see what happens with the module, because it's actually, it can be a good example to use an LLM with Dagger, because there are a couple of interesting things happening in the module. But here, let's see what we got as input. So I see that there is a new directory. So I'm going to show you. So the directory has a couple of files. It's a complete. If I do a Dagger functions, it should build properly. So here, yeah, Dagger can actually build and introspect the module right away that was generated. It works out of the box. So I'll show you the code of the module to see what we have. And so that's entirely generated. In the comments, I see that I instructed the module, and actually the LLM, to keep the original Docker file as in the comments, so I can actually see what has been translated. And here I see native Dagger codes on the Go SDK. So I can see the different stages of the Docker file, and so I will actually run it. I'll go back to the initial directory. Again, you can copy paste simply this command, and so you don't have to figure out what other function names to call. So here again, we are writing this. We are calling this time the new module. Actually, I renamed it to my module, I think. So I need to rename that and call build. And then I pass a local directory. So usually in a Docker build, you have a context directory that you use for copying your code and things like that. So here, that translates into an argument that's called local directory, and you give it the context exactly as you would do in a Docker build. And so I'm calling this time the module that was generated. It's actually pretty fast because I think I have a couple of things in my Dagger cache. That's another advantage, is I can rerun that several times and work on my pipeline, making it evolve and everything. And everything that doesn't need to be redone is just taken from the cache, like any other Dagger pipeline. So here, what I see is the new Dagger, the new module that was generated returns a container. So the advantage is that I can take this container and do other thing with it. So for instance, if I want to make my pipeline evolve, add functions, install Dagger modules to do, like, for instance, scanning or anything like that, I can do it. The interesting thing is there is an exposed port in there, because the example is actually to run an app. So I'm gonna call up on that container, so it will run the service. And here I have a service up and running. It's basically my app. So I'm not sharing my browser. But it basically shows a simple to do app. If you do it yourself, you'll see. But if I called localhost 3000, I can see that it's a JavaScript app that replies on the port 3000. And so yeah, and that's it. So I have this new module that works, that I can use. And obviously, you can use this Docker to Dagger module to translate pretty much any Docker file. It happens sometimes that you have weird syntax, like for instance, if the Docker file is using an experimental front end, there are some things that will be hard to translate, but you will end up with code that you can modify. So even if you have a small mistake in there, which can happen, you can figure it out easily to fix it. And so yeah, and that's about it. And the rest is I was just planning to show you some code, but very quickly, because I want to leave time to Solomon for his demo. But that's the code of the module itself. So basically, you can reuse that as an example to do other. If you have an idea of a project of using an LLM, building an AI app, and leverage Dagger for the cache and for the DAG engine, you can also look at the code of this module as an example. Because the interesting thing here is the module, as you saw before, is leveraging the cache of Dagger and exporting data. So here, I created a directory, I generated a bunch of files. It's fairly simple, as you can see, because it's actually the LLM doing the heavy lifting of taking every single line of Docker file and translate that into a Dagger call. But basically, what is implemented here is on top of the prompt, we give the LLM a couple of examples. So there is an example module that's taking a bunch of examples of, here is a Docker file and here is the how it translates into the Go API, and the LLM is quote understanding. it's not really smart, but it's taking the example as to replicate that to Docker files that it never saw before. So yeah, basically that's how it works. And that's about it.
That's amazing. You can generalize from just a handful of examples. That's so cool.
Yeah, that's pretty amazing. Pretty amazing.
Yeah, it works pretty well. I tried with a lot of different Docker files, and I was very impressed. It really feels like you ask someone to translate for you. It's just that it takes a few seconds. So.
Nice. And one of the questions that came in is, what about build platform and target platform, especially when converting a build that's using BuildX Builder with multiple native nodes?
So I tried that actually. I tried with Rust example. I remember that had a targeted platform for Linux, and I'm using basically I was translated to another platform. It works. It depends if you rely on BuildX to. It really depends on if you're using, like as I was saying before, a specific front end for some instructions. Like for instance, I know there are some experimental front end that add some options when you do a copy with specific mount options in your Docker file that can, there are only 3 examples right now in this that we provide to the LLM. So over time, I was planning to identify what's not working ideally, because I fixed a bunch already. That's why now I'm able to translate a lot of different Docker files that the LLM doesn't know. And then if we hit like a point where there is something that the LLM doesn't know how to translate, even with an experimental front end, we can simply add an example to the project, and I think it will work. I mean, the results that I had so far, I'm confident that it should be fine. It actually implements arguments, also build arguments, pretty well. It translates that into arguments to the Dagger function. So yeah,
Nice.
Give it a try.
Awesome. And one of the other questions that came in for, all of us are playing with different LLM stuff, but there are enterprises where they don't have access to that. So one of them was asking, does this work without AI? And for context, it's like if they didn't have access to an LLM.
So right now it does not. I actually started to implement a static generator that's not as good as the LLM, unfortunately. But technically doesn't. It should be doable to have that static generator be implement pretty much everything that the Docker file implements. So basically, TLDR is right now no. It doesn't work without an LLM. But
But you could run one locally, right? I mean, I'm sure.
You can run it locally with pretty sure you can adapt this this module to use a local LLM via Olama.
I would do
Pretty
that.
sure. I don't know if that would be acceptable for different organizations, but yeah, if the concern is to send the data to a remote API, definitely the local LLM option should work as well.
Nice.
For
No
that.
one needs to know.
Or you can
he
also
says on air
ask a human
in a recorded demo, saying the name.
Yeah, I mean,
asking the question.
There's so much potential here. Oh my god, you could have like your own for people that like OpenAI. You could have like a custom GPT for your company, maybe, or people want to play with DeepSeek, or people want to, like say Olama locally. I mean, it's, I don't know,
and those are all swappable. I mean, it's literally the same API.
Yeah.
cool.
Yeah. Insert AI tool here.
I have to say buzzwords like DeepSeek occasionally. People are like,
right, exactly. We got to come up on all the algorithms.
Stock market moved somehow.
Tag everything. Awesome. Thank you, Sam, for that. I appreciate it. It's very cool. And then we Sam already added the link in the chat, and also added the link in the general chat in our Discord too. So hop in there if you have any questions, or you want to play with it and you're getting stuck. Our Discord channel is the best place to go for that. So thanks, Sam, for joining. Appreciate it. And Solomon, I know you had a demo too, and let me pull yours up.
So how do you want to do this? Because there are 7 minutes left.
Yes.
I mean, if you want, I can just come back next time. I could use the practice, honestly. I can try and do a short version, but it was not going to be 7 minutes short.
I think if either any of our speakers or my fabulous co-host has to go while we're doing it, and feel free to drop off. And you and people who are watching, obviously, we'd love to have you. Like we mentioned earlier in the call, sometimes we also use these community calls to honestly just play with new things and try out some new demos. So if you want to be with us for the ride today, you're more than welcome.
I love how Miranda, you always give a disclaimer before I specifically demo. You're like, remember, it's okay if it's rough. Okay, Solomon, go. Remember, everyone.
Well,
it looks really terrible and shitty.
No, the demos are always amazing. The thing is that they go into such detail that it's exciting to see. But just in case they're new users, this
is not a slick commercial demo. This is the opposite. It's a technical exploration. But it's today's hack is tomorrow's slick commercial product. So
exactly, and that's what's exciting.
Who's that? There's a bot publishing something like that.
Oh yes, cool. And you're doing the whole thing I was talking about earlier. Kind of have Dagger Cloud on the side.
Is that us releasing? Are we releasing something? No, I don't know what that is.
Then we had to release.
It's a robot. Okay. Anyway,
that's the bot. As if you use a cloud token and you're not logged in.
Okay. So it's something in our production. Okay.
Okay.
So let me try. So my demo is also an AI demo. We built a bunch of these modules. I would say Sam's module he just showed is probably the most useful. And we're all exploring, how to build AI tools using Dagger. And Sam's example, the reason it's more immediately useful is because it relies on the most simple and most reliable primitive of models, which is to give you text. You give them text, they give text back. So chat completion. And there's this other feature that is potentially very powerful, but also very early, and people are figuring out how to use it, right? And that's tool calling, right? You can give the model a bunch of tools with descriptions of what they do, and then the model can, when it decides, call a tool, and then the client, your app, is responsible for doing the work and sending the result back. And so the model ends up being the orchestrator, and the result is what everyone is calling now an agent, right? And so building agent is really hot. Everyone wants to do it. And we were wondering, can Dagger help build agents? And the spoiler alert of the answer is yes, like in uppercase. It's pretty crazy how good of a fit it is. But basically think of this robot as two parts. There's a brain and there's a body, and you get a plug of the two, right? The brain is the LLM, and the body is your software. And the way people do agents right now is very monolithic. It's a big ball of code, everything intertwined. But now people are realizing, oh no, this is actually not scaling very well. We should break it up. We should break up the monolith. And it turns out the ideal architecture is really a DAG of smaller agents orchestrating lots of tools. And the tool orchestration part is really important. So breaking up a monolith into a DAG of repeatable tasks, that sounded very familiar. So we're all trying to plug Dagger into this tool calling system. And we've been doing it with modules. So we've been making special modules, kind of like SAM, right? Here's a module that does XYZ with an LLM and tool calling. But the really to fully take advantage of the architecture, you need composition. And so you don't want just one module that's AI aware. What if all of Dagger was AI aware, and all of your Dagger modules could be orchestrated as tools as part of an agent workflow? So that's my demo. So basically, I modified Dagger with the help of several maintainers. So thank you for helping me with my beginner problems. But this is a modified version of the Dagger engine that basically has built-in AI capabilities. I know that sounds corny, like everyone's trying to shove AI in their product, but I promise it's good. So this is a Dagger shell, and what I can do is I can run any pipeline I usually would. For example, I could say, I don't know, like, okay, let's get the source code of Dagger. Hit the main branch. Let's get the tree. Let's get the docs, right? So now I have oops. I have this directory object. Let me pull it. Always the empty cache. Come on. Okay. And then, I can explore the directory. Oh, it's in there. Cool. It's the docs. Okay. Does it have any? Where's the actual content? Is it in there? Anyway, so now I have this object, right? This type, this directory type. Now, notice this function in the docs. Every object has it. If I go back to the GitHub ref, oh, it also has an agent. Convert. Oh,
What?
That's the same type. This Git ref can also be converted to an agent. This Git repository can also be converted to an agent. So basically, any Dagger object can be converted to an agent. What does it mean to convert into an agent? It means you take this object, this instance of an immutable object with an API, that's Dagger, this Dagger object, and you plug a brain on it, and the object as the body of the robot, because it's got functions, right? It can do things, and the brain, the LLM acts as the brain. And between the two, we implement what I call a BBI, a body-brain interface, because I think it's a cool name. And that's a way to automatically introspect the API of that object, whatever it is, and expose it to the model as tools. And so that's the equivalent of the brain waking up and being like, oh, I have a body. What's this? Oh, this can build code. What's this? Oh, this is a Docker file generator. What's this? Etc. Okay, what's my task? And now you can prompt it, and then it's going to figure it out automatically, right? And it kind of works. So, for example, I can do. Let me get this doc. So let's get the docs of Dagger, and then say agent. And now I have this new agent. It's a directory agent, right? And now I can say, and these are the primitives of an agent. You can basically ask it to do things. So this is prompting and prompting, the variations, and then you can run, and then you can see the history basically. So you can say, for example, hey, what is your purpose? For those of you who watch Rick and Morty, what is your purpose? And then look at the history. So never mind. That's ask is a convenience. It just returns a string. I'm designed to help you manage directories. My purpose is to assist with tasks. What is he talking about? Okay, something about directories, building Docker containers, and more. Wow. Okay. Cool. So please list all .md and .mdx files.
Do you always have to ask nicely?
Well, initially, it's funny. It was called do, but then do clashes with there's a bash keyword called do, so I had to quote it every time. So I changed it to please. Okay, so you can see here, it figured out how to call the glob function in the directory. It actually messed up because it's, it used it wrong. So I'm going to say, I'm going to inject a prompt first. You can kind of stack, you can chain prompts, right? When using glob, don't forget about the Daggernauts pattern. There you go. Much better.
Nice.
Okay, so it's thinking. It's thinking a long time. I don't know why it's so long. This is the API. This is us waiting for, in this case, OpenAI.
Maybe it's a very long list of files.
Yeah. Okay, well, so this is the history. So if I go back, it says, here's the list of all the files. Okay, so that was, I guess, now I'll say...
was it long, Solomon? Because we round tripped it through them, right? So like...
Yeah, we did. But it was only the list. It shouldn't have been that long, but I don't know. Yeah, I guess we did, yeah. Pick one of the files at random, read it, and summarize it to me. So know that right now I'm using tools to consume data, right? So you can see this is me trying to. So it got the file. It opens the file, right?
Caching helped to get the list.
Caching helped, yeah. And then it loads. It does chaining. So it got the file, which is an object. It got the ID, and now it's saying, okay, give me the contents of that file. Okay, it's got a graphical, okay, whatever. And now I'm going to say, this is kind of a lame example, but write the summary to a new file at summary.txt. Remember, I'm talking to a directory, right? I'm saying, do this, do this. I have written the file. Okay, it correctly did that. Okay, cool. But what do I do with it? Well, you can get the state back. And it's typed back to the original type. So I got a directory now. And I can get it back. And I can be like, okay, let's see that summary. There it is. So you can kind of round trip to any object. And this, obviously, the directory type is not AI aware, right? And so, but this also works with any type. So I can be like, if I just take the Git object itself, right? We got this API for getting tags, etc. So what happens if I say, hey, what's your latest stable release? So it's gonna be like, oh, okay, that's a bug. Sorry, damn it. Oh, let's see, it figured out. Okay, I have a call to list tags. I can filter by patterns. It did this by auto discovery, so it figured out. Okay, this is the answer, right? Okay, this also works with random modules, right? So for example, I can say, we got the Wolfie module, right? Look at that. It's got, well, hold on. Cache. Come on. I loaded these on purpose in advance, but I don't know what's going on. Big module.
Is this using the one out of the repo, like the local repo?
Yeah, I don't know. Anyway, so here it is, and you can see. Oh, look at that! It can be an agent. Let me get a Wolfie agent. No history. Okay, right. So, what is your purpose? State your purpose. And functionality. We're gonna have like some sci-fi tone here. Oh wait. Okay. Normally, what ask does is just it injects a prompt and then it gets the last message in the history. Okay. I'm here to assist with the configuration of Wolfie Linux environments. here's what I can do. Okay, cool. What you're going to do is build me a container with a starter kit for React web development.
For Alex. For
and it's exploring the API of that module, right? So it found the container function. It's saying, okay, let me give it function packages, and I'm missing some tracing that I had before, but okay, basically this is what it did. You ran this, your Wolfie Linux has been successfully built. Cool. Give it to me. Oh, wait. What type will I get?
Yeah.
Oh, yeah. Okay, so this is a bug. This is where okay. Alex, FYI, we have a bug. By the way, Alex has been helping me a lot on this, so thank you, Alex. We got it to work with modules, but you cannot get the state back. You get this is actually the correct object. It just sends it as a string. So, coming soon. But normally you would just get the container, right? Okay, so the last thing I want to show is the reason this is nice is that you don't have to implement AI awareness into any of your modules. They already are AI aware, basically. Amazing. So, okay, to drive the point home, one more that I like. I tried earlier. I got this Termcast module, and actually this is one of the modules, just like Sam's module before, where it has some explicit AI calls. It did. It's a generator. It's a module that generates like schema style recordings. You can say run this command, or even pretend this command is being run, and then it produces the schema format and then animated GIF. It's really cool. And I added for fun, this is a while ago, like a year ago, an extra function that you give it an OpenAI key, and then it says, imagine a recording, right? And basically, that last night I was like, I don't need this anymore, and I removed it from the module. By the way, I removed a bunch of dependencies, so now it's faster to load. Because I can just do this. I can. Why is it reloading everything? I don't know. Could have sworn I preloaded my cache. I can just do. Let me just slow roll it for a second.
You didn't sacrifice enough tea.
Yeah, I guess not. Well, it's working, so the gods are like, all right, fine.
Yeah,
it's gonna work. That's a lame offering. It'll work.
We need to use our affiliate link for new giant NVMe drives.
Okay, so normally I can do things like you're basically chaining, like I can simulate keystrokes, right? Keystrokes, hello there, and then I can either get a GIF out of this, or I can play it live. I think if that works, I'll be like, we're waiting. I know. I guess we could look in Dagger Cloud. What's going on? Look at that. Oh, okay. I guess we lost. It was too fast. Okay, never mind. Forget that. The point is now I can make it an agent, and so I can say, please record this scenario. A Russian hacker logs into the Pentagon and wreaks havoc. Add lots of cool sounding gibberish. Commands like in a movie. Okay, so it's going to be like it's injecting its imagination stuff into purpose-built tools, right? You can see it's kind of calling the API to chain these stupid little commands.
I love how they just named themselves Russia hacker at Pentagon.
Yeah, a little on the nose there. Well, this is where
I'll never suspect.
This is a good example because where does multi-agent come into this? And actually, multi-agent is kind of the cherry on the cake, to be honest. But it's where it's going. I think really, in my opinion, agents, the way they're being built today, we're just not going to scale. This big ball of Python or TypeScript is just not going to work. And it reminds me of the early days of PaaS, of web apps, you know, the monolith. And then what happened? You started splitting it up into microservices. But in order for that to happen, you needed some sort of a underlying runtime that could run both, right? Which was Docker. And so I think Dagger can play that role here. But the point is, even before you get to multi-agent, you need multi-tools. So I think it's going to be a gentle ramp up from tools orchestration to multi-agent orchestration. And I'll show what I mean. Oh, did it work? Oh, but I can't get the state. Oh, why is it not caching? Should have cached that one.
Functions don't cache like module functions still.
But I thought they did within the same session.
That's a good point.
Literally, someone corrected me about that last week, but now I thought I stood corrected, but I'm not. Anyway, so you get the idea. It's simulating. It's giving me the object, and you can see here. Well, anyway, it would be more fun if I could read the result, but coming soon. Okay, so the last part of my demo is that this is everything you can do in command line, you can do in code, right? Therefore, in theory, if I were to try to develop a little like a tiny toy Devon equivalent, hypothetically, we would call it Melvin. You can start seeing your Dagger module as an agent. And the key is you don't start with the prompts, you start with the tools. And then, because you're building the body of the robot first, you build like a brainless Melvin with all the tools it needs to get the job done, so that you can drive it yourself from the command line to get the job done, whatever the job is, or from software. And then you plug in a prompt, and then you build up from there. And that's, I think, a much more elegant and scalable way to build a model. So here, an agent, sorry, there is zero AI code in here, but it's Devon-like functionality. So it's a toy version. So what does it do? This is like if you develop the Dagger module, you'll see, okay, this is really basic. It's like 176 lines of code, and really most of that is boilerplate. So you give it a repo to work on, and a GitHub token, right? And then you can select one issue as in a GitHub issue. You give it the number, and then that issue, you can interact with it in different ways. You get a workspace, which is a directory for files. You're going to need that, right, for developing. And then I added a bunch of convenience tools. There's a function called contents that returns the contents of the issue being focused on, right? And you can decide if you want the comments or not. And I just wrap the GitHub CLI in a container, right? But I just inject the token, so it's just ready to go, right? You can get the repository, right? That would be useful. Check out the code. You can leave a comment, right? Like same thing, just GitHub CLI. You can check out the code. I guess that's kind of redundant with the other one. This is for looking at the repo and like interacting with it in as an ephemeral object. This is for checking out the repo, a given branch or tag at the given path in your workspace. So we're adding constraints to the agent, right? We're giving it more specialized tools with less open-endedness. And what I'm seeing is agent developers basically have to decide all the time, okay, how much freedom do I give the model? And it depends on the circumstances, and it's a fluid line. Sometimes you mess up, you don't give it enough, and sometimes you mess up, you give it too much. And the nice thing here is you kind of, it's not set in stone. You can kind of evolve. I can add this very specific function, or I can say, you know what, here's a function to like have access to the full Dagger API, or here's a full, a container. You can do anything you want. Here, for example, I'm starting constrained. There's read file. You give it a path, and it's just going to open that file in your workspace. But you see how it's a really thin abstraction on top of basically the core API. And I added find, so I can, same thing, just find files. And write file is the interesting one. This one I'm simulating a regular stateful function on top of what is really ephemeral stateless operations, right? Since in Dagger, everything's ephemeral by default, but you can build stateful on top of stateless if you want, right? And this is just for simplicity. Models are like, oh, write file, that's what I need. So you give it Rails. Okay, so where's the agent? Well, the body's built, right? So now I can do, okay, let's go here. I'm going to sacrifice a repo here. I'm going to create an issue. I tried one earlier, but okay. Upgrade. What would be a good example? Actually, I don't know. Well, okay, let's say something stupid like add documentation. We should have an up-to-date list of all the modules. This is my repo with my experimental modules, like this one, of all the modules in the repo, neatly listed in a README. It should have basic information like name, description. Well, that's gonna be tricky. And 3. Maybe that's enough for now. Oh, 3 Dagger engine version it requires. This can be done by looking. Of course, I'm over-explaining here, but this is a good habit if you want external contributors. Looking for Dagger modules. They are directories with Dagger.json, then inspecting files from there. All right, this may be, I'm not promising that this task will actually be accomplished, okay? I just want to try. Okay, so what can we do here? I'm going to try doing it manually so you get a sense for it. So, I need to pass my GitHub token and give it a repo. I guess I'll do it locally. I'll use my local dev version. Okay. GitHub token. You guys still there?
Yep.
Still engaged? Okay.
Yes, yes.
Okay. So, I don't know how to, we have a gap in the shell. I think we can't get the doc of the constructor. See what I mean? I guess we can. I'll just try doc. Okay, repo. Oh, required arguments. It's right there. Why is it not? I feel like I'm having a very basic problem here. Isn't this exactly what I'm supposed to type?
No, it needs the token as an argument, like second argument, it looks like.
Oh, it's mandatory. Okay. Blah. Thank you.
Right.
Okay, then we're talking. Thank you. Okay, so now I can select an issue. I'm going to select issue 5. Okay, let's see if it works. Can I read the contents? What is up with my cache? I got a caching problem. Okay, this is working. Can I comment? Cool. Oh, it's me. It's going to be weird. Okay, so we got the basics, right? So now let's try. Please solve the issue. Keep the team informed of your plans and progress. Take the time to think in steps, blah, blah, breathe. Insert AI engineering. Okay, let's go. So it's thinking. It's looking at the contents. Good start. It's going to comment. Oh, it's commenting. I will start addressing this issue. Da-da-da. Okay, let's go. Do it. It's looking for Dagger.json files. I attempted to locate. Yeah, because you didn't check out. Check out. Okay, I did it. It's yeah. It reminds me of Devin.
Right.
Okay. Oh, you've checked out the repo. This is really over communicating here. Good. Okay. I have access to Dagger.json.
Your junior engineers, you want them to over communicate. It's good.
Okay. Oh, 010. Wow, that's an old one. Okay. I didn't get the description, but that's fine. I wonder if I can. Remember, I'm messaging myself, I guess. Remember to oops. I don't think it's going to read it. I don't think it's going to read it. It's not checking the comments. I forgot to say that in the prompt. Too late now. See, this is a good example. Like, this is software engineering. Oh, the loop should include checking for the comments. Go back, try again, right?
Right.
Obviously, this is not a production-ready agent. Here's a final batch. I will now proceed to create a draft. Okay. Oh, I really wanted to add the ability to actually push code back, but I didn't have time. But this took me like 45 minutes to develop.
Wow.
I have created a draft of the README file. Okay, cool. Have you really? Okay, this is, remember we were talking about the need. It's rerunning everything. It didn't cache. This is why we need object persistence ASAP in Dagger, because the way actual Devin and every other production agent works out there is that they do this asynchronously, right? They have an additional layer on top of the runtime that's watching for events, like you got a message or there's a new comment in GitHub, and then it loads the state of that particular session. And then it prompts some more, and then the agent does some more work, and then at some point it stops and it saves to resume later. And that's what we don't have. We don't have the primitive for an object to be loaded and then prompted and then saved for later. But we're really badly going to need it if we want people to actually run this thing in production. This is not a production grade agent platform, but it is a production grade runtime that can power a higher level agent platform, I guess is my point. But it needs one or two extra primitives. And I guess it's starting over now. Oh, man, I guess I can't see where it created the file. I just want to see it create the file. Oh, we can see it in Dagger Cloud. Okay, I'll end with that. All of this is traced. So you can monitor what the robot's doing, actually in real time.
Nice.
Here. Once again, Alex, I am begging you for for an actual string here. Oh, that should have been a request from before.
You already used up your one request, so
yeah. Well, but I have 3 wishes, no?
Okay. Until he's like off camera now, so they can make any wishes.
There it is. Look, it called write file, and it wrote to README. Can't see the contents, but I'm sure it's great. And that under the hood calls the actual core with new file, and you can see it mutating the state. Okay, and that's it. So that's my demo. A 45-minute development of a little robot.
Look at using the custom OTel spans too.
Oh yeah.
Make little
Oh yeah.
The emojis. Very
I
cool.
started, yeah, but see, there's a little bug like here. There's I guess here it worked. Yeah,
Yeah.
I'm starting to use that. So in conclusion, I would say we accidentally built, I think, the perfect runtime for agentic systems. Not the whole platform. You need to orchestrate and you need to manage events. You need to scale out, right? Dagger doesn't do that. But the perfect runtime for it, I really believe so, because it's best modeled as a DAG of immutable objects that flow through ephemeral functions with caching and tracing. You're going to need multi-language composition. The big ball of Python is not going to cut it. It's pretty amazing how this is exactly like the transition from web app monolith to microservices, but for agents. It's like from blob to DAG. And we were just doing that for CI. We're doing exactly that for CI, the big YAML blob to a nice clean DAG. And by a stroke of luck, AI agents fundamentally work the same as CI pipelines. You just got to make a platform that's general enough, and we did. Like the tracing, we were looking at Alex's feature before. Like, it just works. This is not CI, but it just works because we didn't build a CI product. We built a DAG engine. Anyway, obviously this is very exciting to me, and it's very fun to build. So you're going to see more of these demos. Hopefully next time it'll be more polished, and there'll be an actual useful thing coming out of it.
Yeah, it's one of the things we people are really excited about it. And some questions around documentation and how to get started, and that's something that our whole team is working on. We even had an internal hackathon of everyone kind of playing with this internally. So as we find specific use cases and best practices, obviously you'll always, all of you watching, you'll see us come back on these community calls and demo like this and show off some stuff, and then we'll include it in our documentation and blog about it as we continue to move forward. So
I forgot the last piece, the multi-agent piece. So this is a bunch of tools that you can prompt, right? So you build the agent from the ground up from the tools, knowing that it can be prompted. So you build the body of the robot. But what if your robot needs to call another robot? Well, you can prompt from anywhere, right? So for example, let's say, get container, get a container, ask the DevOps team for a custom built container. And you say, purpose. A detailed description of the container you need for the DevOps team to build. Remember that they don't know the specifics of your stack or tool chain. Okay, and let's return a container. I'm going to say DAG container. This may not work, but as agent, it's in the API. Why not? Mm-hmm. I don't have to pass tokens or anything because Dagger takes care of that. Please, and I would just probably juice a little bit of prompt engineering, like, you're the DevOps team. What the build. Custom built container for a developer. The developer request is something like that.
Yeah.
And then you get the state, and notice that it's typed correctly to the Dagger container because it's an agent. It's a brain connected to a container.
And any context knowledge that you want to include here could be included to help with the prompt.
Totally. Yeah. And you can. Oh, wait. I'm going to say the base distro is Linux, is Alpine. The app source code is mounted in the work tier, is in the work tier. Feel free to inspect it. And here we could just say, before calling the agent, we're going to, with directory. Hold on, I'm going to set the work tier. This could be us saying, okay, the DevOps team has some constraints, like they have to work from Alpine or from our golden image or whatever, right?
Right.
So this is, again, moving the line, like what's in code, what's locked in code, and what's flexible left to the model. You decide, right? Here I'm deciding it's going to be Alpine. With work tier, app. And then with directory, I'm just going to mount the workspace, right? And then I'm going to turn it to agent. Okay, let's try. Check out the code and inspect it. Ask Hub's team for a container that can build it. Make sure it has ImageMagick installed. Last time we forgot that and wasted time. On deployment, I'm guessing this would be like a GitHub issue or something. I just want to see an agent calling an agent. Is non-unique. What? No. Okay, that might be the end of that. Yeah, I guess there's a bug in my thing. Oh, I don't know why it didn't trigger before. Okay, maybe how about this? Don't check out the code. You will be developing a web app in Go using WebAssembly. Nice. Okay. And there it is. You got an AI calling an AI.
Nice.
Unfortunately, I don't know what they're telling each other. Anyway. Oh wait, it's because Alex wanted to avoid everyone being drowned in huge text. So if the string is longer than a certain length, then it breaks. But you know what I'm going to say? When talking to the DevOps team, keep your messages under 120 characters. That should actually
super terse mode.
There it is. It worked. You see it?
Yes.
Nice.
No more E too big.
Okay. Well, now what will the DevOps team do? The DevOps team is like, what is this? I didn't do anything. Okay. Well, okay. I'm going to leave it with this. But yeah, you get a glimpse of the possibilities for multi-agent because it's basically just tools all the way down. I really just think that, our agent architectures need a Docker moment. They need a Unix moment. They need like a few simple primitives that you can stack up and not this madness that I'm seeing right now. That's not going to work. Anyway. The end. Thanks for sticking around. I don't know if anyone's still watching, cool. But
no, we definitely have people watching. But if people have ideas or this is sparking some conversation internally that all of you are having, like we want to talk about this stuff. So we have an AI
come to Discord.
Channel. Yeah, on the Discord we have an AI channel. So come in there, talk to us about how you're using it, and then like I said, if you want to try out any of the stuff or be one of the first users. Discord's the best place to be too, because we kind of share links in there all the time. But we'll be back on these community calls showing you the latest as well. So thank you, Solomon, for showcasing what
Thank you.
we're building. Awesome. Well, have a great day, everyone. And thank you again for spending some of your week with us. We really appreciate it. See you next time.
See you next time. Bye.